Okay, so if I was thinking of subtraction as a difference, I might be just looking at the distance between 8 and 23. And if I could figure out what that distance is, then that's my answer. So one way that kids sometimes do this is what they'll do is they'll look and they'll say, well, I can add 2 to 8 to get 10, because 10's an easier number to think about. And I can look at adding 2 to 23 to get 25. And if I look at the difference between 25 and 10, that number right there is 15. And that was an easier difference to look at than the difference between 8 and 23. Now, one thing about this, though, is that to understand that this is a difference, you have to understand that if you add 2 to both your minuend and your subtrahend, that you end up with the same difference. And so it's pretty sophisticated thinking, but pretty cool thinking. Now remember, you can record it with an open number line, and what I like about the open number line is it really shows that that difference of 15 stays the same if you just shift both the minuend and the subtrahend up by 2. If you write it with symbols, though, if a kid says, well, I know that 8 plus 2 is 10. What I could do is just write, well, you're taking 23 minus 8, and what I hear you saying is, I'm going to add 2 to get to 25, and over here, I'm going to add 2 to get 10. And that the difference between 23 and 8 is the same as 25 and 10, and then I know the difference between 25 and 10 is 15. I might even think of the difference as taking away right there, but really that shift, when you went and added 2 here and added 2 to keep the difference constant, that's what makes thinking of subtraction as a difference as opposed to something else, even though at the end you might use a takeaway metaphor or a how much more.